Hello, everyone. Thank you for joining, and let's embark on this journey in which I'm going to share some lessons learned from maintaining SDKs for 3 years, mostly in Python because that's what I'm going to focus on, but also in other languages, JavaScript, Go, and a couple others as well. So, as I mentioned, I'm a developer at Metis, and what we do over there is we build an observability solution. The rough idea is that we would like to basically build a component that is going to help developers make sure that whatever they do across their databases is not going to break the production, both performance-wise and correctness-wise. So we would like to build something that will help developers, is developer-centric, developer-first, and provide some value. So let's see how we did it and what happened along the way. So the way we work is we generally want to build a solution that is providing the experience for developers that really covers everything they do around databases, no matter whether they connect to SQL databases or NoSQL databases directly, or whether they use ORM, or whether they use any other technology. We would like to make sure that when they interact with databases, those applications that they build interact with databases, they are going to work well when deployed to production. That means that the queries generated by ORMs are not going to slow down, or that the migrations are not going to take the database offline for a prolonged period. And this includes many other things around schemas, around indexes, around triggers, around stored procedures, everything that affects the SQL and NoSQL database performance. We're going to focus mostly on this part of the scenario. The other big part around how to build understanding on observability of the production system is something that we also cover, but we will leave it for some other time. So the idea is we would like to basically build something that integrates with your environment, so with your application as you develop it locally, and extracts everything that we need to tell you whether, hey, the moment you deploy this to production, this is going to work well or is gonna fail badly. So this is the idea. We do have a couple of assumptions. For instance, that, well, most of the applications nowadays are kind of web-based or cloud-native based. So they are generally exposing some web APIs, REST APIs, or whatever, and we work in this request response pattern. And this is the only assumption that we kind of take. We want to focus on something that develops and deploys the experience for anything that is required in modern world, meaning that no matter whether you are in cloud or on-prem, no matter whether you are cloud native or using some frameworks that do not let you be cloud native, whether you're running that with modern stack or something older, we'd like to support that. We would like to support modern CI/CD deployments, everything around. And generally what we want to do is the solution needs to be super easy to use and needs to be developer friendly, meaning that you integrate it just once. You don't need to do code changes. You don't need to drag and pull many dependencies, ideally none of them at all. And generally, you just add one component to your ecosystem and bang, you know whether what you write is going to perform well, whether your SQL queries are going to be fast enough, whether you have indexing done right, everything just out of the box. So this is the idea. Now, we went over the time. What we did is we went through a couple of iterations how we build all of that. But in order to do that, we always had the same idea. We wanted to capture the interactions of the application with the database, meaning that, hey, there was this SQL statement executed. There was this REST API being called. This is the workflow that the user triggered in your application. And as part of this workflow, such and such SQL query has been executed. And we always want to get the execution plan and statistics and metrics indicating how it worked locally. Then the idea is, once we have all of that, we can easily project that onto the production database and figure out whether it's going to scale where or whether it's going to fail in whatever reason. So this is the idea. This is what we do at a glance. We provide a component that you install to your application like in many ways, and we'll go through those many ways along the journey. And this component is basically a piece that integrates with OpenTelemetry and uses OpenTelemetry to extract the workflow from your application. So like what the API has been called, extract the SQL queries, and then do some magic, analyze the execution plans and whatnot. And we would like to do the same, provide the same experience for all the languages that we want to support: Python, Java, Ruby, JavaScript, Go, anything else, right? We want to cover everything that is developer-centric. So we took 3 different approaches, and I'm going to quickly explain those approaches, and then we are going to go through the lessons learned and what happened. So the very first approach was we built the SDK per tech stack. So we started with, okay, let's build a tiny library that you would install with pip install, with npm install, with Nugget, with Java, Maven, whatever you use. This one tiny library would know how to bootstrap itself once you start the application, and then would figure out everything that goes through to your database and what happens. That was approach number 1. Approach number 2 was slightly different. Instead of integrating directly into your application and doing some craziness over there, we focus much more on integrating with the database and extracting more data from that angle. So this is what we built as an approach on number 2. But finally, we switched gears again and moved to a completely different approach that had no library at all, no changes to the database, and had much more reusable components that you could use along the way. So let's see those in details. The first approach was SDK per tech stack. So the idea here is quite straightforward. You have your application that could be whatever, fast API with whatever SQL Alchemy, whatever you use. And the idea is your application starts. This can be application deployed locally. This can be application that you started in unit tests or whatever else. And you basically triggered some entry point. So someone called an API that you expose, right? So this is what we get. So then your web framework captures this API, and then you have some business code, probably calling some ORM like SQL Alchemy, getting entities, getting data, and whatever. So this is number 2. Then, obviously, this SQL query goes to the database to run the select star from table or whatever. You return the data across many layers of your application, and finally you return them to the user. So this is the idea that we had. So you have this application over here that does all of this magic and basically covers everything you generally have. Now, what we add with Metis is we want you to install basically a tiny SDK. You do pip install. And now this SDK, what it's doing is it is kind of integrating into your ORM library. That could be SQL Alchemy or whatever else, and tries to hijack those queries in the sense of that it wants to get a hook when a query is being executed. Once we do that, we know what query goes to the database, and then we can go to the database and extract the execution plans, extract statistics, whatever, and finally send them to the platform for further analysis. So this is the idea. Now let's see how it happened and how it works. So obviously this approach is pretty good in the sense that it is super easy to install from the developer experience. You just do pip install and that's it. It integrates with your language. So if you need to adjust this solution, change its config or whatever else, you do it in the idiomatic way, in the Pythonist's way. You don't need to go through crazy YAML files or change text configuration or whatever. No, you have nice Python API that does the magic. So this really gives you this benefit that you have little to no changes in your application to get all of that.
Adam, something happened and I don't know where. Adam?
I can hear you.
Okay, for a moment you disappeared. So
Okay.
Shut up and you continue, and then we will put together the 2 parts of the video, okay?
Okay, that sounds good to me. I hope I'm back now. Okay. So we're right. So couple of disadvantages of this solution. So obviously we have the Python-oriented approach. So we have the solution that works but can be reused between languages. Something that you can't really move to JavaScript, Java, .NET, whatever else. You can't reuse this solution, and that is a problem. The problem in the sense that we would like to keep the maintenance low and simple, and it's kind of hard when you need to maintain multiple code bases. Another issue is, obviously, we need to support the tech stack you have. You have different version of Fast API, you need to support it. You migrate to new version, we need to support it as well. You want to run this on Windows, Linux, Mac, wherever, we need to support all those scenarios. And this poses problems. That is because we ultimately have exponential increase in the numbers of how many tech stacks we support, right? There are tech stacks that differ enough that we effectively need to have a slightly different SDK tuned for this particular tech stack. This can apply to what unit test library you use, what web API you use, what like web server, ORM, etc., etc. So while this works, and it's pretty cool from the developer perspective, it's kind of hard actually to be used or to be maintained over a longer time. I mean, it's easy to build the first version. It's kind of hard to keep it to version like 3, 4, 10, wherever, especially over many years. So what do we want to do next? So we would like to take another approach. We want to minimize the maintenance burden that we had with the first solution. So the maintenance burden can be slightly minimized in this way. What we are going to do now is we have a very similar solution as before. So start your application, you have some web frameworks, some ORM library, but now notice that the SDK flags itself slightly earlier in the process. So it flags itself before the query goes to the database. So what we do then is we capture the query. We have this query is going to be executed, and we want to timestamp this query. So we want not tiny string, command, whatever, that we will be able to recognize later on that this is the query that has been sent to the database on behalf of your application. And then we capture the logs from the database. We extract the logs, we extract the execution plans this way. What does it give us? Well, the approach is very similar to the previous one. You still need to install the SDK. You still need to have one install whatever, doing the magic, okay? It still works in a very Pythonist way. It is idiomatic, well integrated with your solution. However, the problem now is because we moved this whole thing from inside your application and this from inside your web framework and ORM onto the database side, you now need to configure your database a bit. You now need to, for instance, enable extensive logging. You need to enable capturing execution plans automatically. You need to, for instance, store those logs and persist them for a longer time. So effectively, this is slightly harder for you to use because you need to adjust every single database you have. If obviously you have production database, that is easy. If you have one centralized CI/CD, that's probably doable. But if you have every single developer taking this approach and running your own database or whatever, creating ephemeral databases with test containers or whatnot, then it might be hard to actually build all of that, to maintain the same configuration across databases. So there are many things that may actually not work the very good way. So what can we do next? Well, if we saw that those two approaches are not necessarily the best, meaning that those two approaches do not necessarily provide the best experience in terms of maintenance and in terms of the quality of how we build stuff, we wanted to do a completely different way. So what we wanted to do is we want to get rid of this whole component that is language and tech stack specific. We want to get rid of this component that is kind of integrated application a lot, but we would like to move to something that is very generic and language agnostic and configurable in just one place. And that was the first approach. So the first approach we took is instead of adjusting your application in any way, what we wanted to do is we wanted to have just one agent, one collector on the side that goes to the database directly. And this connection, this agent, this collector would not touch your application at all. And the way we achieve that is we wanted to use OpenTelemetry integration. So this way, because most of the applications, they already have the OpenTelemetry integrated with them, we don't need to modify your application at all. What happens next is we just extract the standardized things from your application thanks to OpenTelemetry, and that's all we do. And then we go to the database. That's the only thing we do, and we extract other stuff from there. So this way, we are not tied to a specific language, to a specific tech stack, to a specific ORM web server or whatever else that you are using. What we do is we simply use the regular approach that you already have with OpenTelemetry, the standardized approach. Most importantly, the approach that is provided and maintained by OpenTelemetry maintainers. So it's not on us anymore. And this works pretty well. It has a couple of drawbacks. It means that because we rely on OpenTelemetry, if there is anything that doesn't fly well with OpenTelemetry, then obviously we are somehow limited. If OpenTelemetry and specifically the instrumentation, OpenTelemetry instrumentation in your language is hard, then obviously it affects us. If it cannot enrich the SQL query or whatever, then we obviously have problems. So generally, those are the pros and cons of this approach. And now let's see what we learned. So generally, over this journey, we learned that we really should focus on those three scenarios, on those three big areas to provide the best experience and to make the maintenance of SDK easily and attainable over time. So those are uniform functionality and how to deal with them across languages, versions management, and finally supporting diversity of the platforms. So the uniform functionality to begin with. So generally, languages are different. It is cool to build an SDK targeting one particular language, but building SDKs for many languages is hard because some languages are statically typed versus dynamically typed. You do have generic versus macros versus nothing of that type. You do have classes or you do have prototypes. You have things that are very idiomatic, so things that you can do and express easily in your language, and things that are super hard to express in other languages, right? So now comes the question, when we are building SDKs, how should we actually do that? Should we use those language-specific features, or should we keep it plain down so it's easier to translate one SDK to a different language to a different platform? Should we keep one implementation across all the languages, or should we have implementations tailored for specific languages? And what we learned is generally we need to rely on standards and only use the subset of the standards where it's possible and push everything on the standards. So we do not maintain anything. That is the most important part. So one example that might shed some light on the issues that we may be facing. We might say that JSON should be standardized and uniform across languages, right? Because JSON is, well, what's hard with handling JSON, right? You just have a piece of text and that's it, right? But there are actually many problems over there. First, depending on the language you are having, you may have different quirks in terms of parsing JSON, especially when we are talking about JSON that should also indicate the type of the object that it represents, not just the type of data. So we have different conventions. We have different ways of encoding like missing values. We have different ways of actually parsing nested structures. And even though you use one library, you learn over the way that those libraries for parsing JSON in Python, JavaScript, Java, or whatever, they really do differ. The same goes for other things like handling caching. handling, sending JSON over HTTP with various HTTP headers, etc., etc. Generally, all those things, even though they are standardized, the actual implementation differ a lot. So what we want to do instead is not only we want to use the standard, the specification, but we also want to use the particular implementation. So what we would like to do is we would like to have an actual library that will provide us with the abstraction and the actual implementation. And for instance, gRPC, that's exactly that. Because with gRPC, you take both the schema, but also the actual implementation of all the parsers, serializers, whatever else, anything that might actually affect and impact how you are running the gRPC, how you're running the code and whatnot. So generally, even though JSON and gRPC in this example should be very similar, it's actually much better to take something that gives you both the abstraction and the implementation. So no matter what you do, always push this maintenance of the implementation to something different and always follow standards. If you come up with something that you built, you designed, you need to maintain it. You need to be the owner. You need to popularize the solution. You need to make sure the solution works well and everything else. So generally, but the more you use standards, the better. Let's move on. What about things like protocols? Should there be proprietary or should we use something well-known, etc., etc.? Generally, with proprietary solutions, it's always great if you build something that you own. That is because you control everything. You do not send redundant data. You do not send the data in a format that would be hard to parse or whatever. But on the other hand, you need to build parsers, you need to build serializers, you need to maintain it forever and ever. Even if it's just a small thing as like the schema of what you send, you always really need to take care of maintaining all of that. On the other hand, if you take well-known solutions, it's much better because you already have the clients, you already have the libraries, you don't need to maintain everything. The problem is you need to do some more juggling when you get the data because the schema you receive may not necessarily be everything you need or may have some redundant data, etc., etc. Still, it's better to go with well-known solutions and standards rather than building something that you own. Carry on. Version management. What can we do around versioning? So another problem that we might face when dealing with SDKs across languages is some versioning. It sounds easy. We have version 1.0.0. For those of you who don't know what Semver is, you have this major, minor, and patch versions. So you have three numbers indicating and showing you what version of application you're dealing with. If you introduce some non-breaking changes, that you increase the patch number. If you increase slightly breaking changes or changes that shouldn't affect big how you deal with that, or you just add new functionality, you increase the minor. And if you do something bigger, then you increase the major version. Sounds easy. But now comes the question, what happens if you found a bug in one language, let's say Python, but this bug didn't happen in JavaScript? Should you bump the version in Python or should you bump the version in JavaScript as well? How should you deal with that? Should you, in other words, should you keep the relationship of versions between Python, JavaScript, Java, C#, whatever? Should there always be the same versions? How do you deal with changes that need to be introduced in only one place? So in one language, just because a bug was found or a new feature was added to the language, or you had to change dependencies or whatever else. How do you deal with this versioning? How do you deal with cross-cutting concerns? How do you log the messages across languages? How do you effectively deal with that so you actually know what's in given version of your SDK? And the answer to that is generally you always need to support all those versions with completely isolated testing, and you should test everything across all the languages. So what we want to do, we would like to start with having isolated environments as much as possible so they can't affect each other. You should use something that really can recreate the environment automatically. Docker, test containers, Nix, infrastructure as code, whatever else. When you find a bug in language, you want to have unit tests for this bug in all the languages, because it's kind of probable that you find the same bug in other languages, in other SDKs for other platforms. So you always need to test everything, even if you change just one line of code in Python in one particular language. That's one thing. Another thing is you always need to consider how you are dealing with those diverse languages in one repository. So you always want to make sure that you can reason about the code. You can reason about the dependencies you bring. You can reason what tools are required by the users to actually run your code, which things may cause conflicts, which things you should use from libraries instead of implementing them on your own. So then the answer to all those issues, or at least a good direction, is always be as explicit as possible, especially around the dependencies, because they may introduce bugs and problems. And another thing is diversity. So languages are different. There are different idioms, different approaches, different solutions to maintain packages, dependencies, testing, whatever else. The solution to tame this complexity is, unfortunately, it's not having one person that knows it all. This doesn't work. You need to have people responsible for the specific domains, specific languages that oversee and they maintain. In our case, we call these people language champions. So we had a language champion in all the languages, and those language champions that met quite often every week to update themselves on how the implementation progressed across those languages. What changed? What was better? How the designs that we are doing will fit in different languages and whatnot. So generally, the approach here is to have this as decentralized as possible and still bring all those people together so they know what's going on. So even if people are not necessarily knowledgeable of other languages, they should be aware of how those other languages impact the SDKs that we are building. So this is basically it. In summary, the less you maintain, it's always better. So generally, avoid building proprietary solutions. Always build solutions that are running on well-formed standards, well-maintained technologies, and solutions that others own. The less you own, the better. Another thing is keep it consistent. Seriously, you can't build many solutions for many languages, platforms, tech stack. You want to keep this amount of work as limited as possible and reuse as much as possible. Otherwise, the maintenance is just killing you, and that is the big issue. You need to deal with compatibility both backwards and forward. This includes new versions of the SDKs, new version of web frameworks, of ORMs, of whatever. And in order to do that, you always need to have everything automated. Infrastructure as code and other stuff that lets you run all your test suites automatically. Test early, test often, test all the possible scenarios you can think of, and generally have more tests than you think you need, because those tests are really useful. And there are a couple other things you probably could include in those thingies. We could go on much deeper into details of how to do that. Obviously, all those things, they are easy to now convey after years of building those, but they're always surprising to find out when we are dealing with that. And dealing all of that said, I'd like to thank you for attending this talk. If you happen to have any questions, I'm happy to take them now. And yeah, that's it. Thank you.